Hey guys, this video is going to show you how we graph quadratics in standard form. So here's a quadratic, a general quadratic in standard form. Remember that the vertex, the math that we've been talking about, to find the vertex, which is that key point in quadratics. So the vertex is going to equal, remember the coordinates for it. The x coordinate is going to end up being the opposite of the b coefficient divided by the 2 times a. So 2 times our a coefficient. And then we take that number and we just put it into our function, right? So we're going to put that opposite of b over 2a into our function and evaluate it. This is the output that we would get if we take this opposite of b over 2a and plug it into our x into our function. Okay? And then once we have the vertex, then it all comes down to just evaluating some points. Another nice point is to identify in standard form when you let x be 0. So we're not setting the equation equal to 0. We're letting x become 0. So we're inputting a 0. This term will always drop out. This term will drop out, and we always get our constant. So remember, our y-intercept will always be 0 and whatever our constant is. Okay? So let's try a couple of these things here. So here's a quadratic in standard form. So when I identify this, b is a positive 6, a is a negative 3. So we have to take the opposite of b, so the opposite of positive 6, which is negative 6, divided by 2 times a. So doubling negative 3 gets us negative 6 also. So when we simplify this, this just becomes 1. So the vertex of our graph is, I'm going to delete this. The vertex of our graph, the x-coordinate at least, is 1. So to see what we get out, we're going to take this value of 1 and plug it back into our equation. So if we take 1 and square it, we get 1. 1 times negative 3 is negative 3, plus 6 times 1, which is just 6, and then minus 1. So negative 3 plus 6 is 3, and 3 minus 1 makes 2. So we know that our vertex is going to be at 1, 2. Okay? The a tells us, just like it does in vertex form, because it's negative, we're going to open down, and we have a stretch factor of 3. So you can go over 1, down 1, 2, 3, which, check that out, by the way, that's our y-intercept, which is just our constant, so 0, negative 1 is a point. Therefore, 2, negative 1 is a point, because our vertex is on that axis of symmetry. And so we have 3 out of our 7 points that we need to graph, so let's just plug in some other values, like, say, negative 1. So if we put in a negative 1, then this becomes negative 1 squared, which is 1. 1 times negative 3 is still negative 3. But now we have 6 times negative 1, which makes us subtract 6, and then we subtract 1 more, which that'll simplify to negative 10. So if you put in a negative 1, we can get out a negative 10, or instead of going over 1 down 3, we'd go over 1 down 9, right? 3 times that 3, which would put us in the same spot. So either way you go, if you just evaluate points or you understand the pattern in between points, you can do either one. Let's try one more. Here's another graph. b is 3, so the opposite of b is negative 3. a is 1, so if you double that, we're going to get 2. So we take the opposite of b divided by 2 times a, so negative 3 divided by 2, which is negative 1.5. Alright, so now we're going to put in negative 1.5, and I don't want to square that and see what it is, so I'm going to grab my calculator and just take 1.5 squared plus 3 times 1.5, and then minus 4. So we get 2.75 out. So if we go over negative 1.5, we go up 2 3/4, so right about here. There's our vertex, right, which lives on our axis of symmetry at that negative 1.5. So here's our axis of symmetry. Okay, so now let's plug in some more points. So if we let x be 0, we're going to get out negative 4. So that just takes care of our opening down problem here. So that point is 1 unit, 1.5 away from the axis of symmetry. So half plus 1 more. There's the reflection point. Let's try -2 or -1, right? So let's put in, say, -1. So -1, when we put that into the function, we're going to get out -1 squared, which is 1, minus, because we're going to get 3 times -1, so we have -3, and then -4. So -3 minus 4, -3 minus 4 is -7, plus 1, so we get -6. So when we put in how come that didn't work out? If we put in a -1, -1 squared is 1. This becomes -3. Oh, did we get out a negative? Shoot. I'm sorry. I'm going to go back to the vertex. I'm going to take, I think I didn't put in a negative. 1.5 squared is the same as -1.5. We'd still get out 2.25. Plus 3 times a -1.5. I didn't. And then we say -4. So it's actually -6.25. My fault, guys. The vertex is actually going to be at -6.25. So that's right here. And that makes sense because when we put in that -1 and we got out -6, that would be right here. And its reflection's right here. And let's just do one more. Let's put in a 1. 1 squared is 1. 3 times 1 is 3, so we get 1 plus 3 is 4. And 4 minus 4, hey, is 0. So when we put in a 1, we get out a 0. And also -4, when we put in a 1, we'll get out a 0. So here is our quadratic. It looks like that. Okay, so that is how we graph in standard form.